A mole is a unit, or have you heard, containing 6 times 10 to the 23rd.
I'm going to show you how to get set up for the double replacement lab in this class. So one of the first things you're going to need is a sample of 2 different kinds of chemicals. You're going to need some lead nitrate, and it may be put in one of these little containers for you. You'll need a sample of potassium iodide, which will also be put perhaps in one of those small containers as well. Probably you'll have 2 different kinds of containers. One will be one color and one another. You need to know which one contains the lead nitrate and which one contains the potassium iodide. If it's not been distributed for you in this way, you're going to have to measure out your own. You need about, that means about, not exactly, but about, close to 0.25 grams of both these chemicals. That is dry weight. It'll be in a kind of a crystalline, kind of like table salt. It looks something like table salt when it's in here. But there are 2 different chemicals. One is lead nitrate, actually. You might call it lead 2 nitrate in this class, and the other is potassium iodide. And then what you're going to do is you're going to put about 50 milliliters of water into a small beaker. It doesn't have to be this small, but you find your own beakers. There's a lab drawer here that has beakers and Erlenmeyer flasks. So that's a really small beaker, and this is a small Erlenmeyer flask. But you're going to find a beaker to dissolve your 2 chemicals in. You're going to put one, perhaps the lead nitrate, in one chemical, in one of these beakers, about 50 milliliters of water, and you're going to dissolve it very carefully. And you're going to need a glass stirring rod for that. Those are found in the lab drawers, and they look something like this. This one has a rubber policeman on the top, but you might find one that doesn't have a rubber policeman. It might just be a glass rod. And you're going to use that then to stir up both these chemicals. You're going to dissolve lead nitrate in one beaker, you're going to dissolve potassium iodide in the other. You've got to be very careful not to cross-contaminate. So these beakers need to be washed out thoroughly before you use them, and to make sure your glass stirring rod has been washed. And so the only lead nitrate is in one, potassium iodide is in the other. There's no mixing some lead nitrate here and taking your glass stirring rod and moving it over to the other one and get it mixed up together. You want to make sure they're separate completely. And it's very, very important that you're careful about that. So you're going to have only dissolved lead nitrate in one, only dissolved potassium iodide, and about 50 milliliters of water in both of those. And once you have those completely dissolved, you're ready to put them together. You can just take one beaker and pour in the other. Then you want to let that solution, which there's going to be some changes you're going to observe. You want to let it settle a little bit. And it's better if you can do that in an ice bath, if we have time to do that. Everything depends on the day and the time, on the time of year and that sort of thing. But a small bucket like this would be perfectly okay. You put a little ice, a little water in here. You don't want to have too much ice or too much water. If you have too much water, your solution here might tip over inside. So you want to kind of have it sitting on the ice and kind of push down into the ice. You're cooling down what's in here, but you don't want it tipped over into the water. So you need some water though, because the water then conducts the cold or the heat away from the solution into the ice. So once you let that sit for a while, then you're ready to start setting up your filtering apparatus. And we're going to be using a vacuum filtration system. And this is what's set up here. So you have an Erlenmeyer flask with a side arm. And this is a Buckner funnel. And this particular Buckner funnel has 2 parts. You can take the top part off. And you're going to seal this up nice and tight so you get a good seal, a good vacuum. We're going to clamp it down into this ring stand. And then the vacuum hose is going to be attached to the side arm on the sink. So I've got a cap on the sink here that is attached here. Then the drain that comes out of the sink itself is designed so this hooks up, the water's coming in here, and you're going to take the tip of this and push it down into the drain so that when the water is going, there's no sloshing of water around and that sort of thing. So we're going to take and put that here. I'm going to make sure. The purpose of inserting the hose into the sink like this is to make sure that the water, which is coming through here at a high rate, in fact, you want to turn the water up very fast so that you get a really good vacuum. Make sure that hose doesn't go splattering all over the lab table. Once you get that set up, then you're ready to label your filter paper. This little tiny piece of filter paper needs to be labeled only in pencil. Do not label this in pen. And then you want to be careful to label it only around the edges of it. So it's around the very edge here somewhere. You're going to label it in some way so that you're not going to be your sample is not going to be confused with somebody else's. You're not going to find it that somebody's taken yours and weighed it or something. Okay, so you want to be very careful about that. Only in pencil, because pencil won't dissolve as you flow the solution through the foam. Then once you get all that done, you're ready to start everything up. You're going to turn the sink on. You're going to put the filter paper in there, and you're going to spray just a little bit of water. And be careful now. This bottle is for water. Don't use the bottle that's labeled for acetone. You definitely don't want to be spraying any acetone down in here. You want to spray just a little bit into your Buckner funnel so that the paper, the filter paper, seals against the bottom of that surface that's on the top of this Buckner funnel. You can see that there's little tiny holes in here, and the filter paper wants to seal down against the surface here really good. And then the vacuum is being created by the flow of water going down the sink using something called the Bernoulli effect. It's going to create a vacuum in here. It's going to pull the water through and allow you to filter your solution a lot better. And then once that has been filtered and you've gotten all the material out, you want to be very careful that you get everything out of the beaker. There's going to be some solid sort of caked around the bottom. And you can use this wash bottle to kind of wash the chemical off of the sides and the bottom and then pour that into your filter as well. So carefully wash it down like this and get it out of there. You might even want to use the rubber policeman on the tip of this glass stirring rod, or you might want to get a, I can find one. Now, of course, I don't want to put my hands on it. That would be just suitable to put things away in the long places. So please put your stuff up properly. Every lab drawer, every lab section had all the materials they were supposed to have. It becomes very, very frustrating when the materials aren't there. But this is a micro spatula. You might want to use that also to scrape material out of your beaker and put it into your funnel. Whatever it takes to get everything in there. You want to try to make sure you don't leave any of the yellow behind that you don't have to. You're trying to collect as much of the yellow material that you're going to get into the Buckner funnel as possible. All right, once that's done, then you're ready to put this material, the filter paper that's going to be on this Buckner funnel, the surface of the Buckner funnel. You're going to take that out of there and put it onto a watch glass. All right, so here's a watch glass. It's just a piece of glass that has a kind of a curved surface. So this curve right here, the bump part of this, is the bottom, and this is the top. So what you're going to do is you're going to take something like a micro spatula here, and just kind of pull the corner of the filter paper up, and then get you a pair of forceps. Well, here we go. So that's on the lab table. And gently pull the filter paper out and lay it onto that watch glass. Now, you've got to be very careful to make sure the watch glass has been labeled and weighed before you start this process. Also, the filter paper needs to be weighed carefully after it's been labeled. Weigh it before you put it into the funnel. So you have to have the weight recorded already of the watch glass. You have the weight recorded already for your filter paper before you start the filtration process. So then we're going to take all that out and put it on this watch glass. This watch glass then is going to be placed into the drying oven for as much time as you have available in the class period. So this is what the drying oven looks like. You simply open it up, put your watch glass in, and close it. And then after it's sat in there and dried a bit, then you're going to store it overnight in this thing right here. And this is a desiccator. Now this has to be opened carefully. The desiccator has a ground glass edge with grease on it, and you have to unseal it by twisting it off and then twisting it back shut. Usually have two people doing this. One person holds the desiccator in a solid fashion, the other sort of twists the top off like this. Okay? And so then the watch glass goes down inside to let it dry out thoroughly overnight. It's really important that you're careful when you pull this watch glass with your material in it out of the oven that you don't touch it with your hands. You might burn yourself. So either use insulated gloves or get a pair of tongs and pull it out. But it cools off very fast. So after you have it out for a minute or two, you can use the back of your hand and feel how warm it is. But then very carefully you grab it with your hands and put it down into the desiccator. And that's going to store overnight. You'll weigh it the next day. And by weighing it the next day, then you're going to, after you weigh it the next day, you can subtract the weight of the watch glass and the filter paper from the total weight, and that will give you the weight of your product. You're going to be very, very careful to make sure you've got the weight of your reactants, both of them. And that's something that people sometimes make a mistake about doing. They'll weigh this whole thing with the chemical down inside, and that's all they record. But that's not recording the amount of chemical that's inside. So what you have to do is you have to weigh the container with the chemical in it, then empty this out into that beaker that has your water you're going to dissolve it up in, put it in there, and then weigh the empty one and subtract to make sure you have the weight of the chemical itself. Because the math you're going to do is going to require that you be able to know exactly how much the weight of the chemicals are, how much the weight of the product is. And that will allow you to get all your post-labs done and make a good grade at it. Because part of your grade is going to be dependent on the math being done right and all the measurements being done right.